Hi, good morning. Myself Prabhakaran J, working as an assistant professor in ECE department at SNS College of Technology. In this lecture video, I am going to discuss about the Unit 1 discrete Fourier transform from digital signal processing subject. First topic of Unit 1 is review of signals and systems. Let me discuss. Empathy of this topic is clear understanding of signals and to recollect the systems and analysis of signals and systems. Signal is nothing but the a function of one or more independent variable which contains some information. It is called signal. For example, electrical signal and non-electrical signal like sound signal and pressure signal. These all are the example of the signals. Signal is represented as a f of t or x of t. T is nothing but the time. There are two types of signal, analog signal and digital signal, which means continuous time signal and discrete time signal. A signal could be an analog quantity, that means it is defined with respect to time. It is called continuous time signal. For example of continuous time signal is like a human voice. There are two types of signal, analog signal and another one is digital signal. A signal that is defined for every instance of time is known as analog signal. See, this is analog signal. Sine wave is a analog signal. Digital signal, in analog signal both time and amplitude is in continuous in manner. Next one is digital signal. The signals that are discrete in time and quantized the amplitude is called digital signal. Both time and amplitude of digital signal is in discrete in manner. See, discrete in manner. Okay. Classification of signal. A signal can be classified into two types, that is analog signal, which is continuous time signal, and discrete time signal. Continuous time signal is nothing but the analog signal, and discrete time signal, it can be further classified into four types. First one is periodic and aperiodic signal, event and odd signal, which is symmetric and anti-symmetric signal, energy and power signal, and deterministic and random signal. We discuss one by one. Continuous time signal. A signal that is defined for every instance of time is known as continuous time signal. Continuous time signals are continuous in amplitude and continuous in time. It is denoted by x of t, which is represented by x of t because it is continuous time signal. So x of t. Next one is discrete time signal. A signal that is defined for a discrete instance of time is known as discrete time signal. Discrete time signals are continuous in amplitude and discrete in time. It is also obtained by sampling a continuous time signal. It is denoted by x of n. Here n is nothing but the samples. See, this is the first one is analog signal and second one is, which is continuous time signal. Second one is discrete time signal. In continuous time signal, both time and amplitude are in continuous in manner, and discrete time signal both are in discrete in manner. And another one is periodic signal, aperiodic signal. Periodic signal that repeats its pattern over time at regular intervals known as period. In other words, after a certain amount of time, the signal will repeat exactly as it did before. A discrete periodic signal x of n is one that repeats its pattern over time with a fixed period capital N. Mathematically, this can be represented as x of n, which is small x of n equal to x of small n plus capital N, where capital N is the period of the signal and small n is any integer representing the discrete time index. This equation signifies that the signal's behavior repeats every n samples. And a periodic signal, it is a signal that does not exhibit any repetitive pattern over time. Unlike period signals which repeat their patterns at regular intervals, aperiodic signals don't have a fixed period. This means that the signal's behavior does not repeat identically over any finite duration. The diagram shows the continuous time periodic signal and discrete time periodic signal. And also this diagram illustrates a periodic signal. Okay. And another one is even and odd signal. A signal is said to be an even signal if the inversion of time axis does not change the amplitude. Example of even signal is cosine signal. Cos minus theta equal to cos theta. Even signal satisfy the condition x of minus n equal to x of n. Even signal, even part of the when we are find the even part of the signal, we have to use x even of n equal to x of n plus x of minus n divided by 2 formula. And odd signal, a signal is said to be an odd signal if the inversion of time axis also inverse the amplitude of the signal. Example of odd signal is sin minus theta equal to minus sin theta. Odd signal satisfy the condition x of minus n equal to minus x of n. For find the odd part of the signal, we have to use x odd of n equal to x of n minus x of minus n divided by 2 formula. Okay, next is energy signal and power signal. A signal which has finite energy and zero average power. This is called energy signal. And formula for energy signal is E equal to limit n tends to infinite summation n equal to minus capital N2 plus n x of n modulus of x of n whole square. And power signal, a signal said to be an power signal, the average power of the signal is finite and energy is should be an energy is infinite. Then we can call it as the signal is power signal. The power signal formula is P equal to limit n tends to infinite 1 divided by 2 power capital N plus 1 summation n equal to capital N to n modulus square of x of n. And deterministic and random signal. Deterministic signal, a signal which can be completely represented by any mathematical equation. The signal is called an deterministic signal. See the diagram. Sinusoidal signal is a deterministic signal. Example of deterministic signal. And random signal, a signal which cannot be completely represented by any mathematical equation. The signal is called the random signal. Noise signal is the example of the random signal. And some of the elementary signal, unit step signal and impulse signal and random signal, which means ramp signal, all are the some standards of the signal. Unit signal, u of n equal to 1 for n greater than or equal to 0, 0 for n less than 0. See, See the diagram. Unit step signal, only the signal present in the positive part of the positive part. Okay. Unit signal is represented as u of n, and x-axis is number of samples, y-axis is u of n. Okay. And another one is unit impulse signal. Del of n equal to 1 for n equal to 0, and it is defined for del of n equal to 1 for n equal to 0, 0 for n not equal to 0. And ramp signal, r of n equal to n for n greater than or equal to 0, 0 for n less than 0. Okay. This is the some of the elementary signal. And system. A system is a set of element or functional block that are connected together to produce an output with respect to one input. If it is digital system, means the input and output signal are in discrete in manner. If it is analog or continuous time system, means both input and output signals are in continuous in manner. Okay. System process input signal to produce output signal. This is the systems. Next. Continuous time system. Continuous time system means it operate on a continuous time signal, produce another continuous time signal. Response or output of the system, y of t equal transform of x of t. Okay. X of t is input of the signal, y of t is output of the signal, which is defined by transform of t of x of t. And discrete time signal, it operate on a discrete time signal and produce another discrete time signal, which is y of n equal to n capital N of x of n, y of. And applications of signals and systems is lot of applications. Communications, audio and speech processing, image and video processing, and biomedical engineering and military applications. Okay. Okay. We will meet in next video. If you have any doubt, you can comment me. We will meet in next video. Thank you.